Around the nucleus in a stationary state. These stationary states are called energy levels. So here we have nucleus. So here we have stationary energy states. Electrons are revolving around the nucleus, lives in stationary states. These are called stationary states. Stationary states. So according to Bohr theory, electron can only live in stationary states, either in this state, either in this state, either in this state. So electron cannot sit in between these two states. So these are called energy levels. Energy levels. The space between two energy levels like this, it's called forbidden state. It's called forbidden states. Forbidden states. So electron cannot sit between two states, which we call them forbidden states. So next thing is that since electron, so what is the energy? So according to Bohr's theory, energy is directly proportional to 1 over n square, and n is called the principal quantum number and which shows the energy levels and energy states. So according to energy levels and energy states, n can be equal to 1, 2, 3 up to so on. So energy is inversely proportional to this principal quantum number 1 over n square. Energy is varying 1 over n square. So next we can describe the electronic configuration of atoms, of elements, atomic configuration. So it's atomic configuration means how electrons are distributed in the states around the atom. So according to atomic configuration, so in S is a subshell of a first shell. So usually we call it subshell, or also called orbitals. So N represents orbits and S, P, D. N represents orbits / shells. S, P, D, F represents subshells. It represents subshells. So according to our electronic configuration, electron can go in 1s square, or electron can go in 1s square, 2s square, 2p square. So 2 is n, 2 represents n is equal to n. It's n, and s and p are orbitals. And similarly, we can go 3s square, 3p square, 3d square. Further, you can see all the atomic configuration in your lecture notes. So, after electronic configuration, we can go towards periodic table. So, in periodic tables, atoms are distributed, or atoms are sitting according to their atomic numbers. So hydrogen has atomic number 1, it's sitting at position 1, and then all the table is distributed like atomic number, helium, and then we have lithium, and then we have other atoms, carbon, nitrogen, oxygen, etc. like this. So next is that the group 3 and group 4 represents group 3 and group 4 represents group 3 and group 4 represents the semiconductor elements of semiconductor belongs to group 3 or group 4. Group 3 or group 4. For example, silicon, germanium, and these are called elemental semiconductors. Elemental semiconductors, and then we have compound semiconductors. And compound semiconductors are like gallium arsenide, germanium phosphide, gallium phosphide, indium phosphide, and so on. So these belongs to group 4. So group 4 means they have 4 electrons in their valence shells. Before going to 4 electrons in valence shell, I will try to introduce another concept. It's called valence electrons and core. So valence electron means electrons sitting in valence shell, valence orbits, last shell and last orbits are called valence shell, and core of the atom means all remaining shells, and the nucleus is called core. For example, carbon has 6 protons. 6 protons are sitting like this, 2 electrons in first shell and 4 electrons are in the last shell. So this is called valence, and here these both, this one and this one is called core of atom. So we have new concept, valence shell and core of atom. So in semiconductor physics, silicon and germanium, silicon has atomic number 14, germanium has atomic number 32, but in silicon valence electrons are also 4, and in germanium valence electrons are also 4. Both have 4 electrons in their valence shell, and remaining is a core. So these 4 are like this. So it's a silicon and 4 electrons in the valence shell, germanium 4 electrons in the valence shell. So these are basic elemental semiconductor. So semiconductor can be divided into 2 groups. Semiconductor can be divided into 2 groups. First is called intrinsic semiconductor, second is called extrinsic semiconductor. Intrinsic and extrinsic semiconductor, these are two types. So these atoms, since silicon and germanium consist of 4 electrons in their valence shell, so they can complete their valence shell by making covalent bonds. They can make silicon 4 electrons, in the valence shell. So other silicon has 4 electrons in the valence shell. So they can complete, both atoms can complete their valence shell by making a covalent bond with the neighboring atoms. Like this, here we have another silicon and 4. So these two are making covalent bonds. These two are making covalent bonds. Similarly, electron is here. Here we have like this. These two are making covalent bonds. And then we have silicon here. And here these two are making covalent bonds. It means an electron in this atom is revolving in around 2 atoms. This one and this one, this one and this one. This electron is revolving around this silicon atom and this silicon atom. In this way, they are completing. In this way, they are completing their last shell with 8 atoms to make that shell a stable shell. So these are called intrinsic semiconductor. Intrinsic means pure semiconductor with no impurity atom introduced. At 0 Kelvin, at 0 Kelvin, intrinsic or pure semiconductor is insulator. At room temperature, some of the electrons gain thermal energy, and due to that gain of thermal energy, they break their covalent bonds and goes to free. They are free electrons. When they leave their covalent bond, when they leave their atom, they are making a free atom like this. If it's going to leave this here, that electron moves here, gone free, but creating a hole here. It's a hole. It's a hole represented by P. So electron leaving the covalent bond creates a hole. Hole means empty state. Electron left from there. We represent that hole with P. So at room temperature, electron gain thermal energy, breaks covalent bonds, and then we have pair of hole and electrons, free electrons and a free hole, and then electron gaining their energy, leaving from here to this and creating hole there. Electron leaving this point to fill this hole, creating a hole there. And this electron can go like this and creating a hole there. It means electrons and holes are moving in the intrinsic semiconductor with the same concentration and producing some conductivity. So they are conductor means they have some conductivity. Intrinsic semiconductor have some conductivity at room temperature, and then we say that at room temperature, because electrons and holes have same concentration, we say that it's equal to Ni. Ni means intrinsic. Ni means intrinsic concentration in a unit volume. So that intrinsic can be calculated with an equation. Ni is equal to B T 3 by 2 exponential minus Eg divided by 2 kT. B is the material property. Eg, energy gap,
जल्दी हो गया.
Energy gap and K is Boltzmann constant. Come.